Hello and welcome to this edition of Dive in About 5. I'm Barbara Knox.
And I'm Daryl Frost.
Today,
Welcome.
today we'll be focusing on fractions as division. So go ahead and you're going to pause the video when we get to the next slide. Go ahead and complete the task either on your own or with somebody from your team, a partner, your whole team. There are some questions here for you to consider while you're solving, and those questions you're also going to see them on the next slide. See you back in a few minutes.
Happy problem solving.
So taking a look at the progression within BEST, you can see the benchmarks that are related to this benchmark from 3rd and 4th grade. And in green, you see all of the benchmarks that we're going to be covering in 5th grade. This is actually all part of the same benchmark. They're going to be dividing two whole numbers that result in a fraction answer, and they're also going to be interpreting a fraction as the quotient of a division problem.
What really stands out to me is looking at what's in green, which is grade 5, right?
Yep.
That interpret a fraction as the quotient of the division problem is really, that understanding is built upon that first statement.
It is.
They really need to see that and make sense of that idea in a contextual situation first,
Right.
before they can look at that abstractly.
Correct. I also want to point out in 4th grade, that last bullet, representing remainders as fractions. In 4th grade, they did divide whole numbers with a single digit divisor,
Right.
where the answer would have included a fraction as the remainder. So looking at this first problem, Daryl, what type of a model did you use?
Well, it has a linear, the context lends itself to being linear. So I thought of a number line right away.
Exactly. And what would the jumps represent on this number line?
The jumps would represent an hour. And we
Okay.
know that if we're thinking about those units as inches, every 4 inches is an hour.
And I get to 24, and if I take another whole jump, I'm going to land at 28, and I know he wasn't 28 inches away. So I'm going to take
27
little jumps, but I have to be able to relate those little jumps back to a whole jump,
Right.
correct? So here's my whole jump, which would have landed me at 28, but I don't need a whole jump. What do I need?
I need 3/4 of a whole jump.
So in this situation, my quotient would be 6 and 3/4. Yes. So this is a problem that's aligned with our 5th grade benchmark NF11. But what work from prior grades does this connect to?
Well, what you just saw previously, and now the 4th graders are getting that this year.
Yes.
But these 5th graders that we currently have, or the 5th grade, have not had that experience. So it's important to point out.
Right. So in the 22-23 school year, we're going to have to maybe fill the gap a little bit.
Yes.
But next year, students are going to come with this understanding.
And the idea that even with whole number division, I can represent the remainder as a fraction, like
so
that 3/4.
This problem could have fit even in the 4th grade benchmarks.
Yes, exactly. Right.
Now this problem, Daryl, doesn't make me think of a line. It's not a linear problem.
No, and I see you have circles here, but a lot of times kids struggle with circles and then decomposing them into equal sized pieces. I could use rectangles to represent those 3 tomatoes.
I could. I use circles because when I think of a tomato, I think more of a circular image, but I definitely could have used rectangles. I'm going to have to split each of these tomatoes into 5 parts so that I can give one of those 5 parts of each of the tomatoes to each of my friends and myself. So if I receive those purplish pink pieces of the tomatoes, and I put them together, it's going to be a total of
3/5
of 1 whole tomato, which is what we would have received.
Yes.
Okay, we've already talked really about the first and third question, but looking at that second question, how are the 4 tasks related and how are they different? What do you think, Daryl?
Well, I think the bottom two, the writing the equation and solve for the expression, excuse me, in order for students to do that, they need to have that contextual understanding.
So if they haven't done problems like the first two,
they're going to struggle. If I'm a 5th grade teacher and I just start with writing equation is equal to, I'm going to have to be very procedural and say that bar means divide, and it's not going to have any conceptual understanding.
Correct. And we know that when students learn procedurally that they tend to make mistakes when they don't remember that procedure as it's supposed to be. So
yeah, exactly.
Thinking about the misconceptions, I'm kind of going to that bottom question. A lot of students will switch and maybe do 3 divided by 2 instead of 2 divided by 3 because they don't remember which part of the fraction is supposed to come first. Whereas when they've learned conceptually, they're going to know I'm starting with 2 whole things and I'm dividing it amongst 3 people or 3 slugs or whatever the case might be.
Yes.
Another misconception that can sometimes occur is with that division line between the numerator and denominator, some students will think of that as subtraction because it looks like a subtraction symbol.
It does.
Right?
So I think the way to address the big misconceptions here when you're looking at your core instruction is the contextualizing and using different models to represent whatever the
and definitely spending
are.
Time there before we ever get to this abstract thinking.
Yes.
We also want to make sure as we're giving them those word problems that we are giving them a balance of linear and area model
yes.
representations. Thank you for joining us for this edition of Math Dive in About 5 with fractions as division. We'll see you back next time.
Bye.